Okay, so everyone's talking about electrification, cars, grids, everything. But it all hinges on batteries.
hmm And right now, that means lithium-ion, mostly.
Which works, but it comes with baggage, right? Cost, where we get the lithium from, geopolitics.
Mm.
It's complicated.
It really is. And, for anyone following India's push for self-reliance, especially in tech, energy storage is a massive piece of that puzzle.
Exactly. Which is why this news out of Bengaluru from the Jawaharlal Nehru Center for Advanced Scientific Research, or JNCSR, feels pretty significant.
It really does. They're reporting a potential breakthrough.
A super fast charging sodium-ion battery. So that's what we're digging into today, what this is, why it matters, and our info comes straight from the Press Information Bureau, the PIB.
Right. So the core idea here is this sodium-ion battery, or SIB. They've built it using something called NASCON-type materials.
NASCON.
Yeah, think of it like a special crystal structure
Yeah.
that's really good at letting sodium ions zip through. It's used for both the positive and negative sides of the battery.
Okay, and the performance, what are they claiming?
Get this. Up to 80% charge in like 6 minutes.
6 minutes, wow.
And a long life, too, over 3,000 charge cycles. That's pretty impressive.
That is impressive. Because sodium-ion isn't totally new, but the older versions, they weren't great, were they?
No, not really. They tended to charge slowly,
Yeah.
and they wore out much faster than lithium-ion. That's been the hurdle.
So how did this JNCASR team crack it? What's the science behind this leap?
Well, they developed a novel material for the anode, the negative side. The chemical formula is a bit of a mouthful. No, bu.
Okay, don't need to memorize that. What's the important part?
Right. It's less the exact formula and more how they engineered it. 3 key things. First, they shrunk the material particles way down to the nanoscale.
Making them tiny. Why?
Shorter path for the sodium ions to travel. Think less traffic, faster commute. So faster charging.
Makes sense. What else?
Second, they wrap these tiny particles in a super thin coat of carbon.
Like a little jacket.
Sort of, yeah. A conductive jacket. It helps the electrons move more easily. Another boost for speed and efficiency.
Okay, nanoscale particles, carbon coating. And the third thing.
They tweaked the anode material itself by adding just a tiny bit of aluminum. This seems to make the structure more stable, helping it last through all those charge cycles.
So clever materials science, really. And you mentioned sodium earlier. Why is that a big deal, especially for India?
Huge deal. Sodium is, well, it's basically everywhere. Think seawater, salt flats. Unlike lithium, which India mostly imports, sodium is abundant domestically.
Right, so lower cost and less reliance on other countries.
Exactly. This lines up perfectly with the whole Admired Har Bharat initiative, self-reliant India. For anyone studying for the UPSC exams, this connection between advanced tech, domestic resources, and national strategy is definitely worth noting.
Absolutely. So if these batteries become viable, cheaper, faster, homegrown, where could we see them used?
Oh, the potential is massive. EVs are the obvious one. Imagine charging your car in minutes. But also stationary storage for solar farms, storing that daytime energy.
Powering drones, maybe?
Yeah, drones, maybe even bringing reliable power to remote villages that aren't easily connected to the grid. It could really help make clean energy more accessible.
And have they put these through their paces? Is this lab bench stuff or properly tested?
They've done rigorous testing. Lots of electrochemical cycling, charging and discharging thousands of times to confirm that 3,000-plus cycle life. They also used quantum simulations, basically powerful computer modeling, to understand why it works so well at the atomic level.
What about safety? That's always a concern with batteries.
Good point. They report enhanced safety features. The materials they're using are apparently less prone to catching fire or degrading in dangerous ways compared to some conventional battery types.
Okay, so it sounds really promising. But it's not on the market tomorrow, right?
No, not yet. There's still that road from lab discovery to commercial product. Manufacturing needs to be scaled up, costs optimized further, but this is definitely seen as a major step.
A big stride forward, getting attention.
For sure. The scientific community is buzzing about it. It really positions India as a potential innovator, maybe even a leader, in next-generation green battery tech.
Okay, so let's wrap this up. We've looked at this JNCASR sodium-ion battery, super fast charging, long life, uses abundant sodium, potentially cheaper, safer, and great for India's energy independence. A serious contender to lithium-ion down the line.
That's the gist of it. It tackles some key limitations of older SIBs and offers real advantages.
And it makes you think, doesn't it? What happens if this kind of battery tech, fast, affordable, readily available, becomes widespread?
Yeah, how does that change things? Not just big infrastructure, but like daily life. What new things become possible when energy storage gets this good? Something for you to ponder.
Definitely food for thought. If you found this deep dive useful, do hit like, subscribe to the channel, and please drop any questions you have in the comments. We do read them.
And just a reminder, all the details we discussed today came from the Press Information Bureau, PIB.